Hi Liz, I will give you an example of the same kind of problem, but not quite exactly the same. So here we go. Let's make the arch 300 feet tall. Let's call it maybe 280 feet tall. We'll go 300. 300 feet tall and 280 feet wide. That would mean that the vertex is right here, smack dab in the middle. And you can find that point because it's half of 280. So your vertex, your HK, is going to be 140, 300. Okay, and so we have some information. We also have other information. We know that there's this point 0, 0 on the curve, and this point 0, 2, or 280, 0 is also on the curve. So we're going to use that information to make us a formula of the form y equals a times, x minus h squared plus k. Let's plug in what we know. We have hk, and we actually have an x and a y right here. So we're going to plug in an x and a y, that's 0, 0, and an h and a k. So 0 equals a 0 minus 280. Oh, excuse me, not 280 here. This is 140 squared plus 300. We're going to subtract 300 from both sides. And we get a times 140 squared is 19,600. I won't use the comma so we don't get confused. And then we divide 300 by 19,600, and we get negative 3 over 196 equals a. And we simply plug this sucker back into our original equation. Y equals negative 3 over 196 x minus h, and our h once again is 140 squared plus k, which is 300. Okay, now the tricky part is to find out, given this parabola, which we will graph here. Let's take kind of a look at this parabola. See if I can remember. Negative 3 over 196 times x minus 140 squared plus 300. And we'll need to probably change the window here. Oh wow, my window's almost good. So let's zoom out this way. Y-max is about 350. There we go. Take a look at this guy and make sure it kind of is what we expect, which it is. Great, so now you need to find a place where you're going to drop a line straight down to, and that line needs to be a particular distance. So let's say, I don't remember what it was, like 280 minus the length of your name, fine. We'll go back to this guy and kind of draw this idea. So let's say we want to figure out the height of this curve at any point on the curve. Fortunately, we just figured out an equation that tells us the height. This y value is literally how high is this curve. We want that to be equal to 280 minus the length of your name. Let's say that your name has like 50 letters because you're Mexican. So that is going to need to be equal to the height of the curve, which we already learned up there was that fancy thing. So we'll set these equal, we'll solve. You'll need to use the quadratic to solve that equation, and then you'll get a particular x value, perhaps two x values, from which you could drop this line. Not perhaps, it will almost certainly be 2. And you'll say, oh wait, there's actually 2 places that I can drop the line, because the distance to the bottom, where I can just barely dip my head in the water, is the same on both sides. And then you can kind of check your results by plugging that x value in to the equation and looking at it on your graph. I hope that gives you enough to get to the end here. If you need a little bit more, let me know. Good luck.